Try one of those. How's that for a beautiful matrix? I think it's pretty darn beautiful. Yeah, yeah, okay. So the determinant of A equals, and again, let's just take the first row, 8 times, get rid of the row, get rid of the row, get rid of the column, 4, 7, 1, 3. Then minus 3, and again, that 3 is A1, 2. 1 plus 2 equals 3. Get rid of the row, get rid of the column, take the numbers that are left, build a little matrix, and then add to that 2. Take the 2, get rid of the row, get rid of the column, and I have 6, 5, 4, 1. Yay? Yay. So what's that equal to? Well, it's equal to 8 times 4 times 3 minus 1 times 7 minus 3 times 6 times 3 minus 7 times 5 plus 2 times 6 times 1 minus 5 times 4. Okay, 4 times 3, 7 and 1. 6 and 3, 7 and 5, 6 and 1, 5 and 4. 2, 3, 8. All right, so what's that equal to? Well, that's 12 minus 7 is 5. That's 8 times 5. Okay, that's 18 minus 35. Right, 18 minus 35 is minus 17. 3 times minus 17. Yeah. And plus 2 times, that's 6 minus 20, that's minus 14. Okay, so that's 40 plus 51 minus 28 is 63. And 63 is the determinant of this matrix. Yeah? Again, how are we going to get good at this? Yes, we're going to Carnegie Hall. We got to practice these puppies. We got to practice. How about this? Suppose, though, you get this matrix. Right? No Keanu Reeves, just a matrix. Remember, I can do this with any row or any column. Okay? Let's he said, let's go back for a second. Let's go forward backwards. So remember 4, 1, 5, 3? Yeah? Well, I did it on that, but I could also do it on the column, right? So I could say 4, and then I eliminate that times 3 minus 1 times 5, and it works out just the same when I do the expansion starting that direction as it did when I started that direction. So go back. I don't want to use this. I want to do this. Yes? So that 0, I put a 0 in, 5, 6, 2, 9, minus 6, 3, 7, 2, 9, right? Get rid of the row, get rid of the rest of the column, plus 0 times, yeah, plus 0 times 0, 3, 7, 5, 6. Okay? That equals 0 minus 6 times 3 times 9 minus 2 times 7 plus 0. Now you're cooking, right? So that equals minus 6 times 27 minus 14. Yeah? Yeah? So that's 13 times 6? 13 times 6? 6 times 13? Yes? Okay? And that's the determinant. Now, do it the hard way. Do it the hard way. Let's do it on that row. And you're like, that 6 is a to 1. It's a minus. So I'm going to be minus 6. Get rid of the row. Get rid of the rest of the column. 3, 7, 2, 9. Plus 5. And again, get rid of the row. Get rid of the column. 0, 7, 0, 9. Minus 6. Because again, that 6 is a to 3. 2 plus 3 is 5. That's an odd, so it gets a minus sign. 6, 0, 3, 0, 2 equals minus 6 times 27 minus 14 plus 5 times 0 minus 6 times 0, and it still works out to be minus 78. Okay? Doesn't matter which row or which column I pick, I'm going to get the same answer. So this column has 2 zeros in it. That would be the easiest way to do this. I could do it off of this one because that's old school. I could do it. But I end up with the same answer regardless of what row or what column I pick. I'm going to get the same answer. So I picked the easy one with the 2 zeros in it, and that just makes my life really easy. But if I don't pick that one, I still end up with the same answer. Ooh, he said, ooh. Okay, is everybody with me? Is everybody with me? Okay. Do we see a problem with this matrix? Yeah, we should. This matrix is going to be singular, right? It's a 3 by 3. It should have a rank of 3, but it's only going to have a rank of, 2. Okay? Can we find the determinant of this? Well, let's say 1 times the matrix 4, 6, 40, and 10, minus 2 times the matrix 2, 6, 8, 10, plus 3 times the determinant of the matrix 2, 4, 8, 40. Okay? So that's 1 times 40 minus 240, minus 2 times 20 minus 48, plus 3 times 80 minus 32. Do we agree? So that's minus 200. That's plus 28 times 2 is 56. Plus 3 times, oh wait, that's what? 48? 3 times 48, yes? It's 144, and that equals 0. Okay? It equals 0. That's a 1, right? That's 144, if you don't like my handwriting. Okay? Beautiful. Beautiful. This is a singular matrix. singular. It's a 3 by 3 with a rank of 2, and we get a determinant of 0. 0. A determinant of 0. Okay? 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 Do we think we can find these things on our own now? Imagine that you had a 4 by 4. Yes? Yeah, now it's going to be fun, right? Because now you're going to wipe that out, and then you're going to get a 3 by 3. And then minus 2, and another 3 by 3, plus 3, and another, 10, 15, 20, 40, 40, 22, 1, 0, 3, right? Minus 4 times 10, 15, 18, 40, 20, 15, 1, 0, 2. And then you've got to solve that yeah. Much better to go to Excel and type the matrix in and hit the button that says determinant, because Excel will do this for you in the real world. Okay? But it's complicated. Can we do these? We need to practice, right? If we want to get this, if we want to understand this, if we want to do this, we need to practice. It's easy. It's really easy. Let me just say that again. It's easy. It can be boring, but it's easy. Okay? Yeah? Okay. 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 All right. Some other terminology that goes with this. Okay? Minor. A minor is a little submatrix that lives in the big matrix. So whoop. He said whoop. Eh. And we'll just make it a bigger matrix. Okay? Exciting? Exciting. So, minor. For example, we have in a matrix what are called principal minors. A principal minor is a minor built on this thing, which is called the principal diagonal. So it only happens in a square matrix that you have this principal diagonal. Okay? In this square matrix, you have these numbers that come down the middle. Now you're saying, okay, where are the minors? Well, A11 is a minor. Okay? So A11 is a minor built on the principal diagonal. A11, A12, A21, and A22 is a minor built on the principal diagonal. And then the whole thing is actually a minor built on the principal diagonal. Is that exciting? Is that exciting? It's pretty exciting, yes? Pretty exciting? Yeah. Okay. You're not as excited probably as you should be. as you should be. Okay, now let's go back here. And here's our matrix. A1, 2, A1, 3, A2, 2, A2, 3, A2, 3, 2, A3, 3. Okay, now how do we find the determinant of this? Remember that we're taking, for example, A1, and then we're building a matrix from those 4. Those 4 are a minor. Okay? Yeah? Okay. So this matrix is a minor of the whole matrix. And when I take the A11, so this is a minor, when I take the A11 and multiply that thing out, this whole thing is called a cofactor. Is that exciting? Yeah. Yeah. Okay. So if I take A12, right? If I take A12, those two things and those two things become the minor. So A21, A31, A23, and A33, that's a minor. All right? And I'm going to multiply that times minus A12. That's a cofactor, the whole thing. Okay? Okay. You're like, oh, what the heck did I take this class for in the summer? This is fun. This is what in economics we refer to as fun. Okay? It's what we refer to as fun. Now, there's all kinds of other stuff about determinants. Okay? All kinds of other determinants, stuff about determinants that we may care about or that we don't. The determinant of A is equal to the determinant of its transpose. So if I have, we did the 2, 3, 4 minus 1, determinant of that, yes? 2, 4, 3 minus 1, those two things are going to have the same determinant. Okay, and it should be pretty obvious. But no matter what, when I take the transpose of a matrix, the transpose of the matrix has the same thing. Okay? So transposing doesn't change it. Is that exciting? Okay. So the other thing I can do is flip the rows and the columns. All right? So instead of 2, 4, 3 minus 1, I can flip a row or flip a column. So I can go, okay, how about 3 minus 1, 2, 4? And the answer is, well, let's do it, right? That's minus 2 minus 12 is minus 14. This is 12 minus minus 2 is plus 14. Yeah. So I can slip rows or columns with each other. I can change the rows or change the columns. I can move them around, right? So I can take this row, what was 2 becomes 1, and what was 1 becomes 2 at these columns. And it changes the sign, but not the magnitude of the determinant. So this was a minus 14, and that's a plus 14. And all I did was flip two of the columns. I could have flipped the rows. Okay? Yeah. Okay. I know you like that. Then there's more stuff, but not really, no? Okay. Let's go on and do something with these determinants.